6.5 is going to be over log properties. So we talked about exponential properties. Well, logs have properties as well. So let's go over a few of these, and they're pretty straightforward. If you always refer back to the conversion from exponential form to log form, these make a lot more sense. So the first one, let's say we have log base A of 1. Well, what does that equal? Well, let's just throw something in there. Let's throw an x in. If we convert this using the above conversion, it says a to the x equals 1. And what do we know? Anything, if you raise anything to the 0 power, it equals 1. We know that. So this would be like it's to the 0 power. So in this case, log base A of 1 is 0. So log of anything is 0. Okay, another one, log base A of A. Well, again, let me just throw in some number, convert it. Well, if you look at that, that's like it's A to the first power, so that shows me that x equals 1. So this guy is 1. So if you take log base, some log base of itself, it's always 1. Okay, another property. Okay, if you have that, a to the log base A of m, if I throw in some x and convert it to log form, that's log base A of x equals the exponent log base A of m, and there you can see that x equals m. So that tells me that a log base A of m equals m. So basically the a raised to the power of log base A cancels each other out. And then log base A of a to the r, what's that going to be equal to? Again, let me throw in an x. A to the x equals a to the r, and that shows me that x equals r. So log base A of a to the r equals the exponent r. Okay, now here's some other ones. And these kind of go back to the exponential properties, where if you are multiplying two exponentials with the same base, you add the exponents. So if you have log of two things multiplied together, we can split that up into two logs with them added. So if they're multiplied, they're added, and if they are divided, it's going to be subtraction. Now, this is really handy. Really, it's a lot handier if you are going this direction with it. If you're taking something big and making it into one log, that's going to be more helpful. In the next section, you're going to see that it's going to be more helpful for us to push something down than it is to expand it out. And then our last little rule for the time being, log base A of m to the r power, we can take the exponent and bring it out in front as a coefficient. Okay, so let's say we want to use some of these properties to rewrite in expanded form. Okay, so let's say I have log base A of x times the square root of x squared plus 1. Okay, so if we expand this out, we can rewrite these guys by multiplying them together. Now, or excuse me, adding, because they are multiplied. Now, right here, raising something to, or doing the square root is the same thing as raising something to the 1/2 power. Then I can take that guy and bring it out front as a coefficient, and we can't really expand it out much more than that. Okay, similarly, if we have, say, the natural log of x squared over x minus 1 to the third, again, I can do the natural log of x squared minus the natural log of x minus 1 to the third. I have division, so I subtract. So then I can bring the 2 out front, say 2 natural log of x, and then bring the 3 out front, 3 natural log of x minus 1. Okay, now it's going to be more beneficial for us to take something in these big expanded forms and write them into a single log. So let's rewrite as a single log. So let's say I have log base a of 7 plus 4 log base a of 3. Okay, so first you can see that I can take this 4 and bring it up and make it an exponent on the 3. And then 3 to the third power is, 3 to the fourth power is 81. Then I can multiply those two guys, and 7 times 81. I can multiply them because this right here is addition, so I can multiply them together. And so we have a log base A of 7 times 81, which is 500 and, let me double check here, 67. Okay. Another example, log base a of x plus log base a of 9 plus log base a of x squared plus 1 minus log base a of 5. Now, I have no coefficients that I would write as exponents. Everything, let's see here, we have these three that are added in, so they'll all be multiplied, and this one is subtracted, so it would be divided. So it would be log base a of 9x times x squared plus 1. Those are all added, so they'll all be multiplied together, then divided by 5. Okay? And our last formula, there's three more properties. If m equals n, then log base a of m equals log base a of n. That's just saying I can take log of both sides of the equation. That's going to be really handy when we go to start solving some of these guys. And then also, if log base a of m equals log base a of n, then m has to be equal to n. That's just an implication, just like last time we talked about if we have the same base raised to the same power, the powers can be the same. And the last formula we're going to look at is change of base formula. Okay, change of base formula says if I have log base a of m, I can change this to whatever base I want. So let's say, and this is the formula, is we do log base b, whatever base we want, of the m over log base b of the a. Okay, the way I like to think about it is this one's higher, so it goes to the top. This one's lower, so it goes to the bottom. Now, why is that handy? Well, if you look at the calculator has only two buttons, log and natural log. You see, we can't change the base. So, if we have this change of base formula, we can change it to whatever base we want, so we could change it to base 10, or we could change it to natural log. So that would be our way of evaluating a log. So for instance, let's say I want to evaluate this log, and we'll be doing more of this in the next section. We could use the change of base formula, and it would be log of 89 over log of 5. Or if you wanted to, you can do natural log of 89 over natural log of 5. And if you evaluate it in the calculator just like that, you get approximately, can't do the approximately very well, 2.7889. Okay, another example. Let's say I have log base 2 of 17. We can rewrite it as log of 17 over log of 2, or natural log of 17 over natural log of 2, which is approximately 4.087. Now, I will show more of how to do those on the calculator in the next section, because we're going to start solving equations of these logs and exponentials. So we'll stop there.